Okay, today we're going to finish up the 3-week modules of ACT review by going over what is clearly the most difficult part of the ACT. Now that is actually the bad news. The good news is that only about 20% or maybe a little less of the ACT science section is actually devoted to conflicting viewpoints. Now, what conflicting viewpoints are is the idea that science does not always agree in any particular time. Scientific ideas and theories, as it states here, are incomplete and constantly being modified. And so many times camps will develop that have particular interpretations of the available data. Now, it's important to understand that these conflicting viewpoints are based in a interpretation of what data and evidence is actually available by scientific experimentation. They are not harebrained ideas but generally they are ideas that just conflict in their interpretation of what evidence is available. And it is common to see more than one interpretation of the available evidence. And so what this section does is present two ideas or two interpretations of information. And what you're supposed to do is understand the hypothesis of each and understand the data supporting each, and then understand how to interpret either new data or questions about whether one piece of data supports one hypothesis versus another. So what it does is it gives you a summary of the problem and then the two viewpoints that are generally involved. Now the passage takes a lot of time because it's usually longer reading and it usually requires some degree of thinking about what's being said. And so when you're actually taking the ACT, you should skip these, finish the other parts of the science, and then come back, because these are usually the most difficult sections. This asks you to compare two opinions about a scientific topic that generally have different hypotheses but the same data. In other words, the same data is given, two different viewpoints interpret that same data, or sections of data that are consistent with their viewpoint, and then you're asked questions about that. Now, it's a total waste of time to try to figure out which viewpoint's correct, because that's not what they're asking you. They're not asking you to make a critical assessment of their interpretation of the data and decide which one has the best interpretation. This test does not ask that kind of question. They don't want to know if you think one is right over the other. What they are going to ask you is questions about assumptions that are made by one viewpoint or another, what data supports one view or another, if new data is introduced, does that help one view or another, things like that. Now, it discusses a scientific topic, and there's always more than one hypothesis, because that's what the conflicting viewpoint is based on. Generally, these hypotheses don't agree, but they may have some degree of similarity. Don't mix up the hypothesis. As a matter of fact, if you have note paper with you, you should write down viewpoint 1 and write out the hypothesis for viewpoint 1, and viewpoint 2, write out the hypothesis for viewpoint 2, because those hypotheses are very important, and it's important not to mix them up. Sometimes the same assumptions are made to come to that different hypothesis. Sometimes same or similar data is used to support that hypothesis. Now, in order to do these, you have to think like a scientist, and that's why the ACT likes these questions. You have to understand the scientific method. Another reason the ACT likes these questions. The only reason that more of these questions are not on the test is, number one, they take a long time, and number two, people would do worse on the test if the test were weighted more heavily in this direction. Don't make assumptions that aren't given in the problem. Avoid that. And we read these sections quickly and effectively, taking notes if you need to on the way through. You have to make sure you have the two hypotheses and how they disagree, and then ask yourself 4 questions. Actually, the original list was 6, and I eliminated 2 of them, and I'll tell you what those 2 are. First of all, what is the basic question? Secondly, what is the hypothesis of each scientist? That is, what is the position of each scientist? And then what is the evidence given for each scientist? And it can be helpful to make short notes of these as you go through. Now, the 2 that I eliminated had to do with what is the flaws of the first and the flaws of the second. And as I read some of these, I found that it was difficult for someone at your level of training to be able to point out flaws. So I don't think I would spend a lot of time trying to figure out what the flaws are. So you find the similarities and the differences between the 2 opinions, and then you might suggest observations that could support or refute hypotheses, because they will introduce new data that you have to interpret. And then, as I said before, you have to understand what each hypothesis claims. As a general guideline, again, you identify agreement and disagreement, you look for the evidence, and then you think about what sort of new evidence might support each. And I can't overstress this, when you're actually taking the ACT, you want to save these for last. The data representation problems tend to be the easiest. You do them first. The research summary problems tend to be next, and you do them next. And then at the last, you come back and do these. If you're running out of time, look for questions about only one of the passages. That is, there'll be a question that says something like, the position taken by scientist 1 involves the assumption that. So all you have to do is read the paragraph about scientist 1. You don't even have to look at scientist 2 or look at any other part to see, and then sometimes you can answer that question in isolation. Okay, let's take a look at one of these potential conflicting hypotheses. So first of all, the general statement. 2 students want to explain why smoke, which is a mixture of gases and carbon particles, from a burning wood in a fireplace rises up the chimney of the fireplace. So these 2 students want to try to explain why smoke rises up a chimney. They also discuss how the chimney's efficiency, the volume of smoke flowing out of the top of the chimney per second, for a given temperature difference between the inside and the outside, is related to the chimney height. So the general idea here is an overall question about why smoke rises in a chimney. But on top of that, they want to look at the relationship between the volume of smoke that escapes from the chimney top and the height of the chimney at any given temperature. Okay? So they're looking at both why the smoke rises and then how chimney height is related to efficiency, which they've defined as the volume of smoke out the top of the chimney per second for a given temperature. So student 1's hypothesis is, or student 1's suggestion is as follows. Smoke rises because the gases from the burning wood are less dense than the air that surrounds the fireplace. Because the gases are hotter than air, the molecules have, now they're explaining why they're less dense here. Because the gases are harder than air, the molecules have a higher average speed than air molecules. Consequently, the average distance between adjacent molecules is greater than the average distance between adjacent air molecules. And so, the gas density is less than air density. As a result, the upward buoyant force acting on the gases is stronger than the downward force of gravity acting on the gases. The gases rise, carrying the carbon particles with them. The upward flow of smoke is maintained as new air enters the chimney, presumably from the bottom, causing more wood to burn. Now, all of that paragraph explains why smoke rises. Now, this next paragraph talks about the efficiency. As a chimney height increases, the efficiency increases. The taller the chimney, the greater the volume of hot gas, and the stronger the buoyant force compared with the force of gravity. Thus, the more rapidly the smoke rises. Now let's take a look at the second student. Now the second student says that smoke rises because wind blows across the top of the chimney. Now you don't know this yet, but this is a concept in physics having to do with the flow of air across a open area. But this does happen. When no wind is blowing, the air pressure at the bottom of the chimney is only slightly higher than the air pressure at the top. However, when the air at the top of the chimney moves at a higher speed than the air at the bottom of the chimney, the pressure difference between the bottom of the chimney is greater than the air at the top forced upward, carrying the smoke with it. The departure of air from the bottom of the chimney in turn creates a pressure difference that forces new air into the chimney, causing further burning and upward flow of smoke. So basically, the more air that goes across the top of the chimney, the greater the pressure difference between the top and the bottom being higher pressure, the top being lower pressure, and it drives the air up the chimney. And as this happens, the pressure in the bottom goes down because the air departs, and this creates a pressure difference that forces new air into the bottom. As the chimney height increases, the efficiency increases. This is because that wind speed increases with altitude. So the taller the chimney, the greater the wind speed at the top, the greater the difference in air speed, the greater the difference in pressure, and the more rapidly smoke rises. Now, as I said before, it's important that you don't try to decide which one of these sounds better, okay? So let's look at our basic question. Why does smoke rise up the chimney when wood is burned? Now, the other part of the question is, why is a taller chimney more efficient than a shorter chimney? What is the position of each scientist? And student 1 says it's a question of density. The smoke is less dense than air and thus rises. This is a result of heat that results in a greater distance between gas molecules, which decreases the density and causes it to be less dense, and therefore the smoke rises. Student 2 says it's all a result of pressure gradient or pressure differences between the bottom of the chimney and the top. When no wind is blowing, the pressure at the bottom is only slightly greater than the top. So even if no wind is blowing, smoke will rise slightly. This difference increases if wind is blowing across the top of the chimney, and the pressure difference drives smoke up the chimney and subsequently feeds the fire with more air. What's the evidence for scientists 1? Well, first of all, the gases are hotter than air because of the burning. It's true that molecules that are heated travel faster. It's also true that molecules that are traveling faster in a given volume will increase the volume, and cause a decrease in density. It's also true that less dense objects float on more dense objects. So if there's a density difference, the less dense object will float. What evidence is it for scientists 2? It's true that the air pressure is slightly greater at the bottom. It's true that when air travels across any opening like this, there's a decreased pressure at that opening, increasing the pressure gradient. It's also true that when air goes up the chimney, new air has to replace it. And it's also true that when the altitude increases, the wind speed increases. I said you really didn't have to go through the flaws, so I'm going to skip the flaws because many times it's difficult for people to understand that. So here are the questions. According to student 1, which of the following is less for gases from the burning wood than for air that surrounds the fireplace? The average speed of the molecules, the average distance between adjacent molecules, density, temperature, and weight. Shut off the tape while you're thinking about this and then give an answer. The answer is density. According to student 1, and if you have to go back and look at it, it's true that the density of the gases in the burning wood are less than the density of the air that surrounds the fireplace. It's not true the speed is less. The speed is actually greater. It's not true that the average distance is less. The average distance less is actually greater. It's not true that the temperature is less. And there's nothing said in the whole thing about weight. When wood is burned in two fireplaces that only differ in height of their chimneys, chimney Y was found to be more efficient than chimney X. What conclusion would each student draw about which chimney is taller? Now, both summaries said that the taller chimney is more efficient. So Y should be the taller chimney. Both students would conclude that chimney X is taller. Wrong. Both students would conclude that chimney Y is taller. Yes. Student 1 would, and there's no difference between the students in terms of their conclusion about the height. So the answer is the second answer. Both students would conclude that chimney Y is taller. Which student if either, would predict that smoke would rise up the chimney on a day when the air at the top of the chimney is not moving? Actually, if you look, student 1 would certainly predict it. Student 2, because there is a slight difference in pressure, would probably predict it. So the answer should be both. Okay. I think that this is the answer that's in the book that I was using, and I think the reason they come to this conclusion is the following. They say there's only a slight difference, but if there's a slight difference, the smoke will still rise. So if you put both, or thought both, or if you thought student 1, because that one was the obvious correct answer, either of those in my mind are correct. When wood is burned in a fireplace, air in the fireplace as well as gases from the burning wood rise up the chimney. Student 1 would most likely argue, now again you can focus on the student 1 narrative if you can't think of this right off the top of your head. Student 1 would most likely argue that the air in the fireplace rises because the air is hotter than the gases in the burning wood, cooler than the gases in the burning wood, hotter than the air in the surrounding fireplace, cooler than the air in the surrounding fireplace. Why don't you decide in your mind what you think the answer is? For air to rise, it has to be hotter than the air in the surrounding fireplace. That's because it has to have increased motion, increased volume, decreased density, and then rise. Remember, the basic hypothesis of student 1 is a decrease in density causes it to rise. And for it to have a decrease in density, it has to have an increase in temperature. Last question. When air in a hot air balloon cools, the balloon and the air descends. According to student 1, that's supposed to be 1, I'm sorry. The best reason for the descent is downward buoyant force is greater than upward force of gravity. Upward buoyant force is greater than downward force of gravity. Downward gravity is greater than upward buoyant force. Upward gravity force is greater than downward buoyant force. Now, first of all, the two that have upward gravity are both ridiculous because there's no such thing as upward gravity. No such thing in general. I shouldn't say that categorically. So the only two that make sense have to do with downward gravity, and the thing descends, so it has to be the downward gravity force is greater than the upward buoyant force. Downward gravity force is greater than the upward buoyant force. I'm going to stop at this point and move on to the second part for the second example.